Alright, welcome to another episode in my book reading series where I read books. This is different from my wild networking series where I just rely on publicly accessible resources. So this is a Amazon Kindle book. I don't know if this is okay or not to do this on YouTube, but this is the one series where I'm not concerned about that, so if it is an issue and this series needs to go down, then this series is going to go down. My goal is just to read this book, unfortunately not to make a... I don't have aspirations of being a professional YouTuber. I have aspirations of reading this book, and I'm hoping this will help me with my focus on that. Alright, so the next section is learning about functions in Python, and let me be clear here, it's not to learn about them, it's to just review them quick, because this book is not a learning Python book. It's just making sure that everyone reading the book is refreshed and ready to go. This is for people who are already familiar with Python, but this actual video series I'm hoping will help somebody learning Python new, I go in based on my own learning of Python. I'll fill in some gaps, and I'll kind of elaborate on what's in this book. So even though this book is not intended for people new to Python, I'm hoping that this video series would be a decent resource for those sorts of viewers. Alright, so this section is on functions. You have seen some Python built-in functions already. Now move on to writing your own. Remember, a function is a mechanism for encapsulating a block of code. You can repeat the behavior of this block in multiple spots without having to duplicate the code. Your code will be better organized, more testable, maintainable, and easier to understand. Oops, and then let me move my bookmark or else I'll get lost. Anatomy of a function. The first line of a function definition starts with the word def, D-E-F, standing for definition, followed by the function name. Function parameters enclosed in parentheses, and then colon. There's also something called a function argument. Those are terms used when you use a function, not when you define it. When you define it, they're named parameters, but when you use the function, they're called arguments. The rest of the function is a code block and is indented. So we see def, function name, parameters, code block. If you were actually use the function, you wouldn't have this keyword here, you just say the function name. But now these wouldn't be parameters, they would be arguments. If a string using multi-line syntax is provided first in the indented block, it acts as documentation. Use these to describe what your function does, how parameters work, and what it can be expected to return. You will find these docstrings are invaluable for communicating with future users of your code. Various programs and services also use them to create documentation. Providing docstrings is considered a best practice and is highly recommended. Def my function. This is a docstring. It should describe what the function does, what parameters work, and what the function returns. So this is what you get if you use that built-in help function. So the usefulness of that tool depends a lot on these docstrings. So if you're writing a function or library or something that you want other people to use, regardless of how wonderful it is, your best bet to get people to use it is to have good documentation, because otherwise, even if it's this magical thing, if nobody knows how to use it, it doesn't really matter how good it is if nobody knows how to use it. Function arguments occur in the parentheses following the function name. They can be either positional or keyword. Positional arguments use the order of the arguments to assign value. So definition, positioned, first, second. Yeah. So this is another thing that trips up beginners is the order of the parameters. So let's see here. Yeah, because oftentimes, if you're looking at more advanced code, they'll use keyword arguments instead of positional arguments. So the beginners sometimes have a gap in their knowledge where they don't understand that positional arguments, that just using a default parameters require positional arguments. So if you have two parameters, here we've got parameters first and second. When you feed in the arguments, whatever you feed in here on the left is going to be assigned to this variable first in the context of the function definition. And then whatever you put in there second is going to be assigned to the variable second in that context. So some people might get confused and say, I want this variable here in this function first to be a 2, so I'm going to put the 2 here, and I want the second one to be a 1, so I'm going to put the 1 there. Now they're not going to get confused in such a simple example like this, but an example where you're accepting positional arguments and keyword arguments, and it gets tricky because you're accepting multiple kinds of arguments. Your parameters are set up that way, so it's not quite clear what you can enter in there. It can get tricky pretty quick. With keyword arguments, assign each argument a default value. So like here you can have a keyword argument and positional arguments. I think you can only have positional arguments followed by keyword arguments. You can't have a keyword argument before a positional argument. Of course I can try that. So let's try that. Oh, and it's taking forever to start up. So while we're waiting for the terminal to start up, I don't know why it's taking so long. We'll continue to read. The default values are used when no values are passed through function evocation. The keyword parameters can be called by name during function invocation, in which case the order will not matter. Okay, so I've got my terminal up here, finally. So let's try defining a function. And we'll use a keyword argument. So param equals test, and then a positional. Yeah, so you can't have a oops, I left off the. So what happened there is I just left off the. Okay. Oh, but now that so yeah, okay. So non-default. This is a syntax error. Non-default argument follows default argument. So you have to have your positional argument first. There we go, and now it goes through. The default values are used when no values are passed during function invocation. The keyword parameters can be called by name during function invocation, in which case the order will not matter. So if I set a default value func default equals hello world, return default. So now if I invoke my function and I don't pass it any arguments, that's okay. I don't need to pass it an argument because I've already got a default argument. But instead of just relying on that default argument, I can also pass it an argument. My argument. There, and now I get that instead because that's what we're returning is. So yeah, this can be tricky for beginners, but let's keep going. When using keyword, oops. Oh, and I didn't move the bookmark, so I'm dead. Okay. Okay. All right. Here we go. When using keyword parameters, all parameters defined after a keyword parameter must be keyword parameters as well. Yeah, afterwards. So you can have positional and keyword arguments, but your positional arguments must be first. All functions return a value. The return keyword is used to set this value. If not set from a function definition, the function returns none. So you can kind of, if you're strong in networking but learning programming for the first time, you can think of the return statement in a function kind of like the default deny any statement in an ACL, except for it's more like a default permit any. I mean, it's not a perfect analogy, but it's good for understanding the idea that a return statement is even there, is going to be there, even if you don't actually include the return line of code in there. So if I were to write a function, func, so let's, I think this is going to be a really good example of that, and I don't know what happened to my computer, it made a noise, but we'll ignore that and move on. So we've already got this func definition, right? F-U-N-C, there we go, it's a function, we can see where it was defined up here. I can there we go, so here it is, we've got def func, we've got a default, and then we're returning the default, right? So another thing I can do, I can redefine it. We'll say new func equals default equals hello world. Okay, and now instead of doing that return default, we can do print default. So now let's do some testing here. So let's just run the original one, func. Okay, so we get hello world back. Let's run the new one, func. So any guesses on what will happen? 3, 2, 1. So we're just going to get the same thing we see here with the original func. Sorry, actually I was wrong about that. We don't get the exact same thing. We get first of all, we don't have an outline. So it actually printed it. So you can see here it did different things. I think if we were in the regular Python terminal, it might have looked more similar to this. But even then, no, it wouldn't. You can see the quotes are taken out, so that would have persisted as well. So different things did happen here. Here we just returned this this variable that was local to the function, and that no longer exists. If I do, let's take a look at the default variable. Default is not defined because it was only defined locally, specifically in the code that belonged to the function. Okay. Yeah, so you can kind of think of functions as like folders and files in a system. It's like putting things into a new file. Like the function is like a new file, basically. Sorry, like a new file. You can think of it that way. And then if you want to do something, you open up that file by running it like that, I think that's a decent way to think about functions. It's really just an organizational structure. Um, but what a function allows you to do is take something that would be, 100 lines of code and just write it down once. And then whenever you need to use it, instead of writing the 100 lines of code continually, you just you just call the function and pass in the things. It's like a, yeah, so functions are really important to use, but I think sometimes functions can be relied on a bit too much. Really, using a function for the sake of using a function, in my mind, is a mistake. If you have sloppy, messy, bad-looking code that works, in my opinion, you're often better off than if you have neat code that doesn't work. And a lot of times, if you're not, solid enough at Python, making neat code isn't really making neat code. It's just obscuring and hiding bad code in a prettier package. And it's like doing a math problem too. Like, showing your work. Obviously you get more on the page. It looks messier. It's not as clean as just showing the right answer, but it shows that thought process that you're going through. So I think functions are important to understand. They're important to use. They're essential for certain things, like these built-in functions. Print. I mean, that's a function. Like, that's absolutely, without that, anytime you wanted to print something, you'd have to figure out what the code was for this and run that line by line. Absolutely not a way to do it, but my opinion is kind of getting the code to work is more important than having the code look nice, which might seem un-Pythonic, but one thing I do want to do eventually, and I do actually have a book here. So the Cookbook. There's another book called Fluent Python that I'd like to go through eventually. I would like to do. I've never really done a full. I've never really done a full front to back tutorial or a book on Python. I did take a class on it, but I've done most of a book or tutorial. But an advanced, next level book, a book that talks about how to design your Python projects, I've never read that sort of book, and that's, I think, missing a lot. That's a gap in my knowledge. Something I really need to do is read a book about how to be successful with Python projects. So I'm curious enough to Google that quick. So it would be Python design is something I'm not super. Yeah, architecture patterns with Python. This looks pretty good. That's the sort of thing I'm just not super. This one looks pretty good. Oh, well, this is. I've actually had a bad. I read Packet and it didn't have a table of contents. I probably skipped that book. This one looks, well, bad reviews. I don't know. I should stop shopping and start learning. But this is something I might want to do too. Learning how to build a game is, I think, a good way to to learn to code at a really high level. But this looks like really good. I'm not sure about this one. It only has 29 ratings. This has 151. Yeah, most input. See, this is what I need. I need a really impactful. You know what? Book that intermediate. Yeah, I'm intermediate right now. I consider myself intermediate. So if this can take me to the next level, because I've found like I'm clearly not. You know, I'm a network engineer who uses Python. I'm not a professional Python developer necessarily. I mean, I use Python professionally, but this book I think would help me get there. So I'm gonna put this in like a wish list or something, or maybe just in my. I want to get the Kindle version, but let me like add this to the cart or like tuck this away, because this I think is going to be a really good book. So yeah, I'll just add it to cart. I'm not going to buy it now because I still got to get through the books I've already got. Oh, this looks like a good one too. Yeah. Well, that I don't really care about that much. Okay. Well, let me stop, because right now what I'm doing is shopping, and instead I need to be learning. Although I'll admit I'm kind of not in a good state to do that today. I need I need a little bit of exercise, I think. Okay, so with keyword arguments, assign each argument a default value. The default values are used with no values. Are used when no values are passed during function invocation. The keyword parameters can be called by name during function invocation, in which case the order will not matter. Invocation is a great word. It's like casting a spell. That's basically what a function is. It's like a spell that you define beforehand and then you cast the spell. When using network parameters, all parameters defined after a function parameter must be keyword parameters as well. All functions return a value. The return keyword is used to set this value. If not set from a function definition, the function returns none. Oops, and I think I still had the bookmark up. Oh no, the bookmark I took off because I was going to turn the page, but I flipped pages and lost my spot while the bookmark was taken off. Shit. Okay, I think I was here. Yeah, I think I just finished reading this. If not set from a function definition, the function returns to 1. Yeah, I remember reading this. I think I accidentally scrolled my middle wheel, so that turns the page. So I wonder if there's settings where I can turn that off, because I don't want to be able to turn the page that way. That's, I think, primarily the way I get lost. I wish there was a way to mark this as the furthest read location without it being like magical and unexplained as to how to do that. Oh, here's settings. Oh, perfect. Oh, perfect. Okay, so can I show? This absolutely has to be on, otherwise I will lose that. Well, what if I turn this black actually? Oh, that's a little bit better, actually. I'm going to keep it black. All right, so next step is functions as objects. Functions are objects. They can be passed around or stored in data structures. You can define two functions, put them in a list, and then iterate through the list to invoke them. So this is where I'm going to break your brain. If you think you're understanding Python, that's a good point, that functions are objects. So we can see here we've got, I defined func here, which prints out hello world. Let's do a type. Oh, I see, the sound is just coming from this terminal here. That's okay. So let's do a type on func. It's a function. So now where things can really break your brain is I can define a list. My list equals an integer, a string, and a function. And look at that, it's valid. I added a function to the list. And we can see when I print it out, we've got an integer, a string, and then we've got a function. This is what a function shows if you're not running it. So we can do my list, access the last index, and I believe we can even call, there we go, and then we can invoke the function listed at the last index of the list by using open close paren. We invoke the function that is there. One thing I am curious about though is what happens if you put the paren here? Okay, so that still works. And what if you call it here? Okay, so now you no longer have to invoke the function. So in addition to it being important to know that functions are objects, just like a integer, a string, a function can be passed around inside other data structures, such as lists and dictionaries. You can pass them around in two different forms. You can pass around the invoked form, or you can pass around the non-invoked form. So for the non-invoked form, in order to invoke it, you need to include these parentheses, and we can see here, we can just reference it without including the parentheses and just see the function without it being invoked, or we can invoke it by including these. If we pass it the invoked version, the only way to see it is after it's invoked. So it's, we might as well pass it just what it returns. There's really not, I think passing the invoked version is probably not as beneficial as passing the non-invoked version, because let's say the function requires input, so new input, we'll say return input. So I didn't give it a default parameter, so you have to pass it an argument now, because it won't know what to do unless it has that argument. So let's try running it without passing it an argument. There we go. And because that's parameter input is positional and is not a keyword argument with a default value, it has to be provided. We can see there's a type error. It is now missing because I didn't pass it. So let's try passing it something. Okay, so now we can see we've got hello world. Let's try adding it to the list. And let's try adding it to the list uninvoked. There we go. Now let's do my list. -1. And we'll try running it invoked. And there we go. We got the same error message we got before because we didn't provide an argument. So let's provide it one. There we go. And now we can run it because we provided it an argument. Just like the other function, we can also provide it the argument here. We can pass it through as invoked. But now when I do that and I refer to it here as part of the list, all I get back is the argument here. If I were to invoke it, it's a type error. It doesn't even register in this list as a function anymore. It's just what the function produced. So if I print out my list, you can see I don't even have the function in the list anymore. I just have what the function returned. So if you want to include a function in the list, you can't invoke the function. So let me be super clear about that. We'll go and we'll redefine the list again. We'll redefine it with it not being invoked. Now we'll print out my list. And now we can see the actual function is in the list and not just what the function returns. All right, functions are objects. They can be passed around or stored in data structures, as we saw. You can define two functions, put them in a list, and then iterate through the list to invoke them. So here we've got double. So if you want to run this twice, you can put it, oh, we got double and triple. So yeah, you could, for function and functions, pass it through. Wow, that's a cool way. This is kind of new for me. Like, this is expanding my knowledge of Python. I'm glad I'm reading this. Anonymous functions. When you need to create a very limited function, you can create an unnamed anonymous one using the lambda keyword. Oh god. Generally, you should limit their use to situations where a function expects a small function as an argument. In this example, you take a list of lists and sort it. The default sorting mechanism compares based on the first item on each sublist. Yeah, lambda for me is like where it starts getting like really out there. You can pass to a function as an argument a function without defining that function if you use lambda, from what I understand. Okay, so here we got a list of lists. So we're sorting those lists using the sorted built-in function. To sort based on something other than the first entry, you can define a method which returns the item's second entry and pass it into the sorting function's key parameter. So there we go, def second item, return second entry, return item 1, so sorted items. Okay, and this is just a part of the, this is a keyword argument that can be passed to the built-in sorted function. But with the lambda keyword, you can do the same thing without the full function definition. Lambdas work with the lambda keyword followed by a parameter name, a colon, and a return value. Lambda param return expression. Sort using lambdas, first using the second entry, and then using the third. Sorted items, key lambda, item, and then here we go, our list of lists. Be cautious of using lambdas more generally, as they can create code that is poorly documented and confusing to read if used in place of general functions. All right, I will be back shortly. Okay, I'm back. Lambdas is one of those things, in my opinion, where it's like, we're writing a language to make, you know, code readable and stuff. Lambda, 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 lambda. It's like, it's just, I'm not a huge fan of lambdas. I never really use them. I only use lambda if I need to do something and I don't know how to do it, and there's a clear example of how to do it using lambdas. Because sometimes like I won't know how to do something, so I'll like Google it, and if the solution I see, like they give me like 5-6 lines of code, like does the thing I need it to do, like I'll use it, which isn't always the best way to go about things because it might do things you don't intend it to do, but I find that's often a better strategy than just trying to think through it because it's just, especially like under pressure and stuff, it's hard to come up with the right answer. And if you can find, if your question is clear enough, and the answer to that is definitive enough, I find there's no problem with just finding. And in fact, there's a book that I saw here that is basically just answers to common questions you have in Python. So the book is Python Cookbook. And then if we go to the table of contents, and say, yeah, so we can see basically all the common questions you might have in Python, finding, keeping dictionaries in order, finding commonalities in two dictionaries, removing duplicates from a sequence while maintaining order. These are all things that you might be thinking about when you write Python. So you can just say, oh, I need to strip unwanted characters from a string. Let's go to section 2.1.1, and then let's see how to do that. Okay, so you can use the strip method. You can use all of this. Like, that's, I think, this stuff is so complicated and so expansive. You can't memorize everything. You can't, you're probably not the Rain Man, and even if you were, the Rain Man, there's just so much data out there. There's so much to learn that the more you can, in my mind, use as a tool, as opposed to discover, invent, and innovate. And I think the more you can discover, invent, and innovate, because you're now working on things that already don't already have solutions. Like, if you're spending a lot of your time trying to find a solution for something that already has a solution, in my mind, you're kind of wasting your time, unless, of course, you don't know that there's already a solution to it. But if there's a solution, it's valid, it's working, it's fine, and of course it's available for use. You're not violating any copyright or laws by using it. I say use it, for God's sakes. Save your brain. To sort based on something other than the first entry, you can define a method which returns. Okay, so I remember reading. Oh, I see. Okay. Okay. Yeah, so I read all that. So next part is using regular expressions. The need to match patterns in strings comes up again and again. You could be looking for an identifier in a log file or checking user input. For keywords or a myriad of other cases. I think it's a myriad. Let me check. Myriad. I was totally wrong. Myriad of other cases. You have already seen simple pattern matching using the in operation for sequences, or the string .ends with and .starts with methods. To do more sophisticated matching, you need a more powerful tool. Regular expressions, often referred to as regex, are the answer. Regular expressions use a string of characters to define search patterns. The Python RE package offers regular expression operations similar to those found in Perl. The RE module uses backslashes to delineate special characters used in matching. To avoid confusion with regular string escape sequences, raw strings are recommended when defining regular expression patterns. Raw strings are prepended with an R before the first quotation mark. Note, Python strings have several escape sequences. Among the most common are line feed, -n and tab-t. So it looks like they're not going to explain what a raw string is, so I'm going to explain that. So let's say we have a string called my string. Okay. And let's say we add one of these several escape sequences. We're going to go with the line feed escape sequence. What's going to happen? It's going to print out, but let's actually add it in the middle here to make it more clear what happens. Well, actually, let's do it here. So we're going to do let's say what we want the string to look like is, wait, why did that happen? Oh, I see. Okay, so what we want the string to look like is we want my on one line and then string on another line. So this is how we would type that, but we can see this is just the value of of what we typed here. It's not on multiple lines because we didn't use a function on it and pass it as an argument to a function whose parameter is taken and searched through for a character like this, and then a special action as defined in the function is taken on that character. So can you guess what sort of built-in function would do that? 3, 2, 1. So the print function does that. So if we print my-n string, now we've got our 2 lines. But what if what we wanted was my-n string? What if we wanted it to be on one line and we wanted the actual backslash and the n to be on there? So what we could do is we could escape that special character by using a backslash. There we go. And now we get that there. What if we wanted 2 backslashes to show up? Well, we can add another escape. Yeah, so we'd have to add 2 escapes to do that. But you can see it gets confusing. Like, what is going on here? You know, it's hard to understand. So instead of doing that, what you can do is put an R in front of it, and now it no longer reads these as special characters. So it'll just print exactly what you have here. Even if you have this -n, it'll print it out like that, and we'll ignore the fact that you have it. You take the R out. Now we get it on 2 lines. So it's basically a way of turning off this backslash from its default action of modifying what happens. So you can say, regardless of the character I give you, just treat this as you would any other character. Don't give this special actions depending on that character. And you can do that by including that R there. So it's really important to include that in regular expressions, because if you're trying to match on a character, you won't get a match if that character has a special meaning. So you can use that R to turn off special meanings and only match on the characters given, not on their special meaning as well. Searching. Let's say you have a CC list from an email as a text, and you want to understand more about who is in this list. CC list equals, is that pronounced king? Okay. If you want to know whether a name is in this text, you could use the in-sequence membership syntax. Okay? To get similar behavior, you can use the re.search function, which returns a re.match object only if there is a match. Import re. You can use this as a condition to test for membership. Yep, so this is another thing that I use a lot. And you might think, oh, well, why can't you just continue to use that in? Just if it's in there, then, why do you need a more advanced RE? Well, I mean, the short answer is, depending on what you're doing, you might not. And regular expressions can sometimes make your code less readable. So, if it's a simple thing you're looking for, just use the simplest possible way of finding it. But let's say, for example, you were looking for a valid IP. You want to accept input from a user, and you want that user to be a valid IP address, IPv4 address. You can write a regular expression to validate that, and then if there's no match, they didn't type in a valid IP, then you can tell them, hey, I need a valid IP. You can't do that just with the in statement, because the in statement to check requires it to match. It doesn't require any variability in what they enter. So it's kind of like a meta abstract way of looking at a string and not saying, you can tell me whatever you want as long as you're talking about food. How do you know they're talking about food? You can use something like a regular expression and look for certain aspects of the thing they are saying without requiring any specific detail, except for what you define. So you can say, give me an IP address, but it doesn't matter what address you give me, as long as there's 4 octets separated by periods, and each octet has a value of 0 through 255. Character sets. So far, RE hasn't given you anything you couldn't get using the in operator. Oh, well, they were going to talk about this next. However, what if you were looking for a person in a text, but you can't remember if the name is Bobby or Robbie? With regular expressions, you can use groups of characters, any one of which could appear in a spot. These are called character sets. The characters from which a match should be chosen are enclosed by square brackets in the regular expression definition. You can match on B or R, followed by OBB, and either I or Y. You can put comma-separated individual characters in a character set or use ranges. The range A through Z includes all the capitalized letters. The range 0 through 9 includes the digits from 0 to 9. The plus sign after an item in a regular expression matches one or more of that item. A number in brackets matches an exact number of characters. Oh, it looks like they're not going to talk about the asterisk. So the plus sign matches one or more of the item, but what if you don't know if the item's going to be there or not? And you want to, if it is there, match it any number of times, as you would with the plus. you can use the asterisk instead, and that includes a zero matching, where if it doesn't show up at all, that you can continue on in your search. One thing that I think is difficult for people to pick up on in regular expressions, or it has been for me, is the fact that it is character by character, left for right. So this CC list here is a variable with whatever they're matching. Let's see if they have a definition for that. They didn't. Okay, so that's confusing. But we can do our own example here. I'm going to do my own example here. Before I read this part here, we can construct. So I'm going to open up my terminal. Here it is. Perfect. And I will import RE. Okay, and then instead of using a variable like they did CC list, let's use a, we're going to do a re.search. Okay, and then the first part of the re.search is what you're searching for. So we got to use this R syntax here so that we know we're not searching for special characters, we're just searching for characters as they are. And I'll search for .com. And then the second part is what you are searching. So it's what you're searching for, followed by what you're searching. So we can see they're searching a variable, but unfortunately we can't see how that variable is defined. So let's search instead of through a variable, just through a string. So we'll do email@email.com. Okay, so now we're going to look for .com in email.com. If it's there, we're going to get a RE match object. So we're going to get an object that is created by the RE library. Got it. And the good thing, the thing to know about that is that this evaluates to Boolean true this object. So you can use this in your if conditionals just to see if it shows up or not. Yeah, I just wanted to make that more clear that this was what you are searching, and this is where you are searching. Oh, right, and then the other thing I wanted to try to make clear, it's a little bit more tricky though, is that what you are searching is actually this part is to be honest a bit of a gap in my knowledge. I'm still not, I thought I had a better understanding of this, but it's a gap still, because I don't understand like how this is searched. Is it searched just left to right? Like how does it know? Like here's a good example of this, of where my confusion is. Let's say we have so we're searching for a contiguous .com string, and we found one here, right? But let's say we have a string like this, m. So we have a contiguous .com string if you were to go .co and then go back to the beginning and look at it. Okay, but we're not finding a match here because it's not contiguous left to right. So I think how it works is, now this is what you're searching for, but this is where you're searching. So it goes through and looks for this, but see, I don't know if it looks for it 4 characters at a time, 1 character. I mean, if it searches for it 1 character at a time, obviously it's just never going to find it because this is 4 characters. So you'll never have a match in 1 character if you're looking for 4 characters. But does it search for 4 characters at a time? Like, what if I have, like, but that's not true either, because there wouldn't be a match if it searched through it 4 characters at a time. I guess this is something I'm not super familiar with, because what if I add, let's do this. So we're going to do, so there's 4. So if I did 1234.com, we're going to get a match, right? But if I did 12345.com, we still have a match. So clearly it's not just searching for 4 characters at a time for a match. Clearly somehow it knows to find this match regardless of how many characters it is finding to match. So this is something I still don't quite understand, how matches are found in regular expressions. And it's still, like, I know how to use regular expressions. I've done the practice exercises, but I still tend to not use them when I don't need to. But anyways, let's keep going. We can construct a match using a combination of character sets and other characters to make a naive match of an email address. The character has a special meaning. It is a wildcard and matches any character. To match against the actual dot character, you must escape it using a backslash. No, you don't. That's what the R is for. Oh. Wait a minute. Oh, okay. No, the R is not for that. The R doesn't mean that in the context of a regular expression there are no special characters. It means in the context of Python there are no special characters. So what you specify here might have special meanings, both to Python and both to a regular expression. So if I were to put a \n here and I didn't have this R, Python would look at that and say, or might say, I'm not too sure about that, but I thought like you wouldn't have to escape this if you're using the R. I'm a bit confused, but I think that is the case, is that this applies to Python, but you can still have special characters in there that are interpreted by the RE library, even if you have this R here. But it's definitely recommended to have it there because you don't want Python to be confused by what you have in there. This example is just a demonstration of character sets. It does not represent the full complexity of a production-ready regular expressions for emails. Oh, well, they added an extra A in there, it looks like. Character classes. In addition to character sets, Python's RE offers character classes. These are pre-made character sets. Some commonly used ones are \w, which is equivalent to that, and \d, which is equivalent to that. So these are just abbreviations for what are clearly long and complicated expressions. They've got like a macro for that. You can use the plus modifier to search for multiple characters. And you can replicate our primitive email matcher with the \w. Perfect. Groups. You can use parentheses to define groups in a match. These groups can be accessed from the match object. They are numbered in the order they appear, with the 0 group being the full match. Yeah, so that's more advanced. But you can say, I want to find, like now this is specific to the search object. It's a feature in the RE library. You can put your matches in groups. So let's say I want to find all of the yeah, let's say I want to find a digit. And I want to find a .com. Oh, but it's gonna be read left to right. Never mind. That's not a good example. Let's just use the example they gave because I'm sure it's thought through pretty well. Oh, but I need to define CC list. God damn it. But anyway, we can see here they specified the group that it matched, and then they've got parentheses wrapped around different parts of their matching. So when they specify it, they get the specific portion of the IP address. They get the name portion, the domain portion, and and then the website portion separated into the portion before the dot and after the dot. And that's because they used parentheses here. Named groups. You can also supply names for the groups. Oh, I didn't even know that. By adding, wow, I didn't know that. That actually could be really useful. I should use more regular expressions in my coding. I kind of shy away from them because they like make it a little less readable, but like I should really use them. Then you can access the groups by name instead of number. Matched equals re.search. Yeah, I should really do this actually. I haven't been using enough regular expressions. I just considered them like to be like, I guess, difficult and unreadable, so I haven't used them, but like they're just so powerful. Like I think kind of one of the problems I have when I code in Python is I just try to do something I try to do something without using extra tools, and I think that instinct is kind of incorrect. Like, if I'm looking for something in text and I don't need to use regular expressions, I just won't use it. But I don't think I think to some extent that's a good instinct, but I think sometimes I take that to the extreme. All right, find all. Up until now, we have demonstrated returning just the first match found. We can also use find all to return all of the matches as a list of strings. Okay, matched equals re.findAll. We got matched. There we go. Find iterator. When dealing with large text such as logs, it can be useful to not process the text all at once. You can produce an iterator object to use the findIter method. Object using the findIter method. This object processes text until it finds a match and then stops. Passing it to the next function returns the current match and continues processing until finding the next match. In this way, you can deal with each match individually without devoting resources to process all of the input at once. So there's still a computer involved, even though Python is trying to make it kind of seem less like that. So you do need to think about what your computer is doing and how much you're taxing it. And you can get huge performance benefits if you think about that and design your code wisely to not overtax your computer when it doesn't need to be overtaxed. The iterator object matched can be used in a for loop as well. Yeah. Substitution, besides searching and matching, regexes can be used to substitute part or all of a string. Okay. You know what I can do? Because I'm working on a project now, which of course I can't talk about, but as I said before, I shy away from using regular expressions, and I think I just need to get over that. I need to stop doing that because they're just like I'm kind of that instinct, I think, to just use the simplest method possible and not use a more advanced method where advanced methods don't seem like they are necessary. Just kind of deprives me of having a advanced method available. So I kind of try to get creative sometimes in the name of keeping my code simpler and not introducing something like regular expressions to it. But I think sometimes that just actually makes me have more complex code because I'm getting creative and gathering my input in a way that allows me to avoid regular expressions. All right, substitution. Besides searching and matching, regexes can be used to substitute part or all of a string. Okay. Compiling. All of the examples so far have called methods on the RE module directly. This is adequate for many cases, but if the same match is going to happen many times, performance gains can be had by compiling the regular expression into an object. This object can be reused for matches without recompiling. Okay. Regular expressions offer many more features than we have dealt with here. Indeed, many books have been written on their use, but you should now be prepared for most basic cases. All right, lazy evaluation. Lazy evaluation is the idea that, especially when dealing with large amounts of data, you do not want process. I think they're missing two. You do not want to process all of the data before using the results. You have already seen this with the range type, where the memory footprint is the same. Even for one representing a large group of numbers. Generators. You can use generators in a similar way as range objects. They perform some operation on data in chunks as requested. They pause their state in between calls. This means that you can store variables that are needed to calculate output, and they are accessed every time the generator is called. To write a generator function, use the yield keyword rather than a return statement. Every time the generator is called, it returns the value specified by yield and then pauses its state until it is next called. Let's write a generator that simply counts, returning a subsequent number. Okay, I'm not gonna write it. I kind of wonder if I should be typing these out, but I didn't want this to be so, I didn't want to spend so much time reviewing Python, although it seems like there are some kind of gaps. I have, but like I've done this before, and it's to the point where like if it's over my head, it's just because it's not useful. Like I haven't seen this used in like a network engineering context all that much, which is why I'm not familiar seeing it. But of course, you know, I could be missing a really important thing that would really help me if I were to understand it better. But I'm gonna skip it and move on. Note that the generator keeps track of its state, and hence the variable n in each call set to call to the generator reflects the value previously set. Okay, that sounds awesome. Wait, no, that could be really useful. Okay, I might need to be using generators more. I wish this weren't nudged down here and like word wrapped. Like I wish I could just have a slider bar, because like this is hard for me to read. Yeah, I'm not a fan of ebooks still. They're too hard to read. We can also iterate using the generator in a for loop. Generator comprehension. See, this is where it gets like I just don't understand this kind of Python like super well. Like it gets complicated. We can use generator comprehensions to create one-line generators. They are created using a syntax similar to list comprehensions, but parentheses are used rather than square brackets. Even with this small example, we can see the difference in memory used by using the sys.getSizeOf method, which returns the size of an object in bytes. Oh wow, look at that difference there. Holy cow. So simply by using parentheses instead of brackets, you can reduce the size of your object this dramatically. Okay, so I need to get better at that. I don't know. Yeah, I don't know how to get better at that, but all right. So the next section is going to be Ipython features. I'm at well past the 1 hour mark. I'm kind of fading fast, so I think I'm gonna call the video here, and when I come back, we'll be reading this section.